thanks for the introduction. My name, again, is Ken, and this is Anatomy of Analytics MVP. So a little bit about me. I care about this a lot because that's what I do for a living. And also, more than that, is last 2 years, I was doing my own startup in data analytics. And when you're in a startup, certainly the pressure of time, the pressure of resource is a lot greater. So this talk is really about getting you up and running. So today I want to flip things around and show you a demo first that I hacked together in roughly a day and a half and really go through its architecture, how I set the whole data pipeline up, and as well as some considerations for when you're building your own MVP. So before we start with the demo, here's a disclaimer. This is an MVP. So the idea is to get your product out there in front of your client, in front of your user as soon as possible with the core functionality that's necessary that they're looking for. And with that is you really want to focus on the problem. And for the demo I'm showing you, the problem we're trying to solve is, how do people like the latest Godzilla movie? So now it's the demo time. Here's the link. So if you're interested, you can go on there yourself. But I already have it open here. It's a fairly straightforward demo. Website of, use the scaling. But it's a very simple website. But the key thing, key thing here is this chart of the latest tweets mentions about Godzilla and whether or not it's positive, neutral, or negative. How do people feel about it? And you can also highlight it to see some of the positive posts, how many counts there are. What are the neutral posts? Quite a lot. Not as many negatives, so I'm pretty thrilled about this new movie. Now let's jump it back into the presentation and really look into, okay, what sort of components are there that composed of this? And just as any good MVP, I designed my architecture on a napkin. You can see we have data feed on one side, put it through a data pipeline, analysis, database, all the way to the visual side, which is what you just saw. Now let's jump into the data feed. Of course, because we're analyzing the Twitter, the data feed here is, well, Twitter. I'm using the Twitter Stream API as well as the the Python client library. But there are plenty of Python libraries that hooks onto the Twitter API. So you can definitely find your own favorite ones. However, when you're working with data feed, the real big question is not so much about the library, but whether or not you want to push or you want to pull. So when you're doing a pull, which is what I'm doing here, you're really you're really connecting to a client API, to an outside API a lot of times, to an endpoint and grab their data. However, at the same time, if you can also define your own web endpoint and have other people submit data to you. So this would be a push type of architecture. And generally, you find push architectures or push paradigms for internal data systems. So, for example, if you're working with internal emails or logs, the data logs, or even clicks or sales, marketing and KPIs, it's nice to have them push to your data pipeline instead, because you can define their interface. You can define what's important to you and have them adhere to your requirement rather than the other way around. Once we get the data, a great thing to do is push it into a queue, because that will separate you from the data feed, the speed of the data, the traffic, the load of the data feed with the rest of your system, and you can handle it as you need to. Now, in our implementation, I'm using RabbitMQ, which is a SaaS product as part of Iron.io. A great thing about it is that it has a really powerful and really easy to use Python client library that helps you hook right onto it. And one of the reasons why I chose an MQ instead of another paradigm I'm going to introduce later is that when you work with an MQ, it allows you to be a fairly decentralized system. The components pushing onto the queue has no idea what the messages are being done on the other end. And at the same time, those taking the data off the queue doesn't really care, and it shouldn't really care about which data, who put the messages onto the queue. So it allows you to have a distributed system, which definitely has its advantages and disadvantages. Alternatively, you can have a worker system where you have a centralized component or a centralized layer or have a particular layer that assign jobs to various workers. You could basically put it on a job queue and then you have other workers pick off those jobs and execute those jobs. Now for those paradigms, it tends to be it's better for a centralized system because the delegator, the manager of this particular paradigm, it needs to know what jobs needs to be executed. It needs to know what module or what libraries are available on the worker to say, I want you to execute that particular function. I want you to execute that particular operation. So it's better for a centralized system, and you tend to see a lot more when you're working with a big data analysis problem where, for example, you're distributing computation for big Numpy job, for example. And here are some alternative technologies for both paradigms. So for an MQ, you can also use RabbitMQ, Memcache. If you're working with a worker, Iron.io also provide their own worker architecture. And RedisQ, which only requires you have a Redis server set up, enables you to implement job queues really extremely easy. Now let's move on to the analysis component, and this is actually some of the lightest component. But this is really where you as a developer, you as a startup, this is really where your core is, because this is the job that you're meant to be solving, the question that you're meant to be solving. So of course, the implementation varies quite a lot. Now, for me, I use TextBlob, which is a text analytics library that lets you quickly implement text analytics features. So all I did is create a text blob, call its sentiment attribute, grab it, and say, okay, given this sentiment polarity attribute, is it positive, neutral, or negative? Now here's some alternative libraries that you may want to use for this. NLTK, Scikit-Learn, of course, Numpy, SciPy. But the real key here for this component is because it's dequeuing from the MQ, you want it to be as lean as possible. It should have as minimal amount of data as possible to carry out that analysis, to carry out that operation. Why? Because it allows you to distribute your problem set, a big data problem set, or however, the load or those problem set into smaller pieces that one machine or one job or one web server or one process can handle. And then you're really using the architecture itself to scale out your calculation rather than trying to do too much with the software and have run into concurrency problem, run into other problems that comes with the complexity. After you've done analysis, the analysis posts the results. The component posts the results onto the database. Now, in this particular implementation, I'm using the Cloudin, which is a database as a service. It's implementing the CouchDB, specifically the big couch flavor, which has better which has more support for distributed computing. Now, one of the reasons why I'm choosing CouchDB, well, the number one reason is because I've used it for a long time. So it gets me going really quickly. But it also has a really great strength. You can apply incremental MapReduce onto it. And you can define your own view, and you apply incremental MapReduce, which, as it says, incrementally MapReduce the results that's in the database. And it's done on every read. So which makes it a great system if you have a heavy read system. So as the data comes in, and on the other end, it's continuously being read by the clients. It's continuously updating on a very, very small incremental basis, and that keeps the particular view, the particular index, up to date all the time. There's some alternatives that you can also use. MongoDB, Hadoop. I'm putting Hadoop in there because this is really the step where you aggregate all your data, aggregate all your analysis. So we had right in the beginning, we had the data feed, grabbing a bunch of data, put it in the queue, and the analysis doing the bitwise analysis. And so this is really where you pull everything in together and generate that and create that internal data structure report that's being fed out into the client. Of course, you can also do that aggregation via SQL database. However, for an MVP, I tend to recommend a NoSQL solution. And the reason is because NoSQL solutions do not require schema. And because you're working with an MVP, your goal is to get your solution straight to the user, to the client as soon as possible, and get their response. The more time you're spending updating the schema, the more time you're spending updating the data structure, the less time you have getting the real feedback from the users. Finally, let's get the data, let's get the analysis results onto the client. So this is the visual component. For the visual component, I'm using Rickshaw, and this is actually not its logo. I couldn't find its logo. I'm using the Rickshaw library. It's a JavaScript library. It's built on top of D3. It renders really beautiful time series charts really quickly. But there are some alternatives I can use. You can always go with D3 yourself. Get your hands dirty on it. MVD3 I also love a lot. It's a library of reusable D3 charts. So your typical charts of pie chart, bar graphs, time series charts, it's all there. It gets you up and running really quickly. Now the reason I put Django in there is because the current implementation uses Flask. Of course, it depends on how much you like, how much you're interested in Flask versus Django, how much you like either one of them, how familiar with each one of them. But I tend to prefer Flask because for this particular layer, it's actually fairly light. It doesn't do a lot of calculation. All it does is it's the layer between the database and the client and the JavaScript. And another charting library, it's GraphQL, which is not a D3 library, it's not a D3 library. It's based on GraphQL, which is another vector-based graphing engine. Okay, so now where are all these things hosted? This is really the big MVP part. You can see here, everything here right now is hosted on one Heroku app. And I have 3 processes running. It's costing me $70 monthly. However, when you're running with MVP, again, a lot of times your data load is not necessarily large enough, so you'll be able to keep yourself within the freemium model, the free plan for a lot of these products. So you can see here I have Cloud running, I have RabbitMQ running. Both of these are still very much the free tier. The dynos, I have 3 dynos running. That's what really contributed to the monthly cost. However, if you do separate those 3 components into their own Heroku apps, you can actually stay within the free plan for Heroku. So you're really running your MVP for free, and you're getting your product out there to your clients. An additional benefit for using something like Heroku, a platform as a service such as Heroku, is that the integration is extremely seamless. I didn't really touch any config values, any configuration issues, aligning them. It's all done internally through environmental configs. Through the only config file that I had to deal with myself is really for my dev machine, not for the production. And you can see here, because I'm keeping every layer separate, I can scale each process separately. If there's a lot of data load on the analysis side, while not as many users, I can scale up the analysis component without worrying about the rest of the system. At the same time, I can scale, if there's a lot of user, but not so much data feed, I can do the same for the web. Now, to finish this up, I want to share some considerations when you're building your own system. First of all, again, got to hammer that in. It's all about the problem, what particular problem you're trying to solve. That is the focus of MVP. That's the focus of your system. Don't really worry about anything else. Let someone else worry about it. Second of all, try not to learn as much. Actually, when you're building an MVP, you don't really learn. You want to minimize your learning because you want to minimize the amount of foreign technologies you're working with. The goal is to get things up and ready as quickly as possible. So if there's something that I already know, use it. Again, when you're on a more larger software engineering side, we all learn that when you're dealing with a big problem, try to break it down to smaller problems, such as when you're dealing with a big data problem, break it down to small data problem. And SaaS it back up. There are a lot of free technologies out there, with free plans that you can utilize. And I've introduced a number of them today that you can utilize to get you up and running. Again, anything that you're really not solving for your client, everything else, try to utilize the available resources out there. For queues and DB layers, these are great buffers that you can utilize to make sure that between different components, you can scale them as swiftly, as smoothly, and as seamlessly as possible. Finally, if speed is a problem for you, so if you really worry about speed, a lot of these SaaS technologies, a lot of these platform as a service technology, DB as a service technologies, they're all built on top of EC2 as well. So when you're creating a new plan, when you're setting up these SaaS products, these platforms for you, try to select the same region. That would minimize the communication required between each component, and that would drastically increase your speed. And that's it. Thank you very much. I think we have some time for questions.
Hello. Yeah, I have some question about like some legal issues, like how to get a data source. For example, like you just mentioned that you use Twitter Stream API or something like that, and I remember that Twitter licensed their data to like two companies or something like that. So if we use those kind of APIs, do we need to pay anything to them?
There are specific. So the Twitter streaming API currently is not. There's a flavor of it that is free. It's limited, of course, in what you can do with it. So what you may be thinking of is Firehose, which is a paying product. So you have to pay for Firehose. The streaming API limits you to particular keyword, particular mention. So you only get stream of that.
Okay. I have another question about. I'm pretty naive to Heroku, and I heard you just mention that you use Flask or something like that.
Yes.
And is Flask the default web framework that you can choose on Heroku, or you need to install it in some way onto Heroku?
Heroku is so for those not familiar, Heroku is a platform as a service. So what you're really submitting to Heroku is just your code. So the library as well as a requirement.txt file. So as long as Flask is within that, you can do it. It also has great tutorials for integrating with Flask, but as well as Django and many other popular web frameworks. You're definitely not limited to Flask.
Any questions or comments? Okay. So if you have any questions, you can talk later. Thank you very much.
Thank you.